Hello, my name's Darren Holmes. Today we're going to be using the Primer Trainer and looking at lesson number 6, 16-bit subtraction. So in lesson 6 we have some new instructions. We have the sub-E command with the opcode of 9.3. Now we've used sub-C, but this is the first time we've used it for the E register. The SBB command with an opcode of 9A. This subtracts the D register and the carry flag from the A register, with the result being stored in the A register. So this actually works just like the sub command, but now we're going to include the carry flag, which, remember from our last lesson, is actually a borrow flag. We have the move the C into the accumulator, opcode 7.9, move A into C, opcode 4F, and move A into B, opcode 4.7. So I just want to remind you the SUB instruction is on page 773 of your textbook, and we're going to be using the E register, so the opcode is 9.3. The SBB command in your textbook is on page 768. We're going to be using SBBD, and you can see that code is 9A. Under description, you can see it says the contents of the operand, register or memory, and the borrow flag are subtracted from the contents of the accumulator, and the results are placed in the accumulator. The contents of the operand are not altered. However, the previous borrow flag is reset. And the three move commands are on page 757 of your textbook. And you can see here that we're moving C, so the source is C, and we're moving it into A, so the opcode is 7.9. And then we're going to move A into C, so the opcode is 4F. And then finally we're going to move A into B, so the opcode is 4.7. So I just want you to notice this sentence in the instructions. It says using the carry flag with subtraction instructions allows you to subtract 16-bit, 24-bit, or even larger numbers. Now keep in mind we have an 8-bit CPU which can store the largest number being FF in hexadecimal. In decimal that's 0 to 255. So that's not a very large number. If we use 16 bits, in hexadecimal that's 0 to FF, that's 4 Fs, and in the decimal system that's 0 to 65,535. Now in 24 bits, that's 0 to FF, that's 6 Fs if you're counting, and that's 24 bits. So that can hold the number from 0 to 16,777,215, and that's in our standard decimal numbering system. Now keep in mind, if these are signed, that means going plus and minus, then we could only store half the size of the number. So taking a look at today's code, you can see we're going to start our program at FF01, which is where we usually start, and the program's broken down into two sections. So we're going to subtract the low order bytes first, and then we're going to subtract the high order bytes and the carry flag. So what we're doing here is we're moving C into A, subtracting E, and then moving A into C. So we're storing the data in the accumulator in C, overwriting whatever number was originally in there. In the second half of the program, we're moving B into A, and we're going to subtract D with the carry bit. So if the carry bit was set, that's going to add to that number. Then we're going to move A into B. So our result's going to be in the BC register pair. And then we're going to halt the program. So they've already got the opcodes down here for us. So we're going to go ahead and load that into the primer trainer. And then we'll come back and have a look at the rest of the instructions. So I'm going to turn on the primer trainer. And at FF01, I'm going to start loading the program. So the first code is 7-9 increment, 9-3 increment, 4F increment, 7-8 increment, 9A increment, 4-7 increment, and FF increment. And then I'm going to step backwards just to make sure that the code was entered correctly. So coming back and looking at the rest of the procedure, we're to load the BC register pair with 2100 hex, and then we're going to load the DE register pair with 10FF hex. It says the following is an equation that the program will perform. So what we're going to do is we're going to take 2100 hex, which is in the BC register pair, and we're going to subtract 10FF, which is in the DE register pair, and the result should be 1001 hex. So with my program counter pointing to FF01, I need to load the BC register pair. So function BC register pair, I'm loading 2100. Remember to press enter. And now I need to load the DE register pair. So function DE register pair, and I'm loading that with 10FF and pressing enter. So after loading the BC register pair with 2100 hex and loading the DE register pair with 10FF hex, we're to single step the program starting at FF01. And it says you will see the following after each step. So at FF01, instead of pressing function run, we're going to press step, and then we're going to check the A register, and A should equal C, which should be 00. So with my register pairs loaded with data, at the start of the program, FF01, I'm going to press the step button, and then I'm going to check my A register. And you can see the A register is equal to C, which is 00. So at FF02, we're going to press the step button, and we're going to check the A register. So A should be equal to A minus E. So since A equals 00 is less than E, FF, the carry flag is set. So we'll examine bit 0 of the flag register. And it says the subtraction will be performed as if there was a 1 digit to the left of the A register. In this case, the subtraction will be performed as if A equals 100 hex. So we have 100 hex minus FF hex, which is equal to 01. So A equals 01. At FF02, I'm going to press the step button, and now I'm going to be checking my other registers. So I'm going to check the A register, And you can see 01 is now in the A register, and the flag register is 01, and that's fairly easy to see that the carry bit did get set. So at FF03, we're going to press the step button, and we're going to check the C register, and we'll see that it equals A, which is 01. So at FF03, I'm going to press the step button, and now I'm going to check that C is equal to A, so I need to go to Function, BC Register Pair, and you can see the C register is now 01. So at FF04, we're going to press the step button, and A now equals B, which is 21 hex. So at FF04, I'm going to press the step button, and it says that A should be equal to B, so I'm going to go to Function A, and we can see that A is equal to B because it has 21 hex stored in the A register. So at FF05, we're going to press the step button, and it says the D register and the carry flag are subtracted from the A register. So A equals A minus D minus the carry flag, which is equal to 21 hex minus 10 hex minus 1, which is the carry flag, and that should equal to 10 hex. So at FF05, I'm going to press the step button, and it says the D register and the carry flag are subtracted from the A register. So I'm going to check the A register, and you can see the contents are indeed 10 hex, and you'll notice the flag register has changed. It's now 0 at the far end, so I'm pretty certain that the carry bit has been reset. At FF06, we're going to press the step button, and now B equals A, which is 10 hex. So at FF06, I'm going to press the step button, and it says B equals A, so I'm going to go to Function and bring up the BC register pair, and you can see that the B register is indeed 10 hex. So FF07 is the end of the program. So we're going to examine the BC register pair, and you will see that it is now 1001 hex, just as predicted in the equation that was shown. So at FF07, this ends the program. If you press the step button, it won't do anything. It won't increment the program counter. It just stops there. So we're going to examine the BC register pair. So Function BC, and this is supposed to be our result, and you can see our result is 1001 in hex, which is the result that we're looking for. And if we go to Function AF, we can see that the flag register is 10, and if I remember rightly, 0 being 000, the last 4 bits means the carry bit was reset, so there is no carry set, and the 1 being in the first 4 digits is the auxiliary carry being set. Now it says here, try pressing the reset button and loading BC and DE with other values such as the C register is greater than the E register, and single step the program again. So to review Lesson 6 on 16-bit subtraction, we're going to use the Primer simulator. I'll turn it on, and we're going to load our code in starting at FF01. So I'm going to enter 7, 9, enter, 9, 3, enter, 4, F, enter, 7, 8, enter. 9A, enter. 4, 7, enter. And FF, enter. I'm going to press reset to take me back to FF01. Now I have to load the BC register pair, so function BC, and I'm to load in 2, 1, 0, 0, and press enter. Now I have to load the DE register pair, so function DE, and I'm loading that register with 1, 0, FF, and press enter. Now we're to single step through this program, so we're going to add the low order bytes together. So I'm going to do my first step, and that should load A with a copy of C. So if I go to function A, you can see I have 0, 0 in there. So if I do my next step, it's now done the subtraction command of the low order bytes. It's taking FF from 0, 0. So the answer should be 0, 1 in the accumulator. So function AF, and you can see in my accumulator the answer is 0, 1, and I have one flag bit set. So I can go to View, Register Contents, and checking out the flag register, I can see that the carry bit is set, indicating that that was a borrow in subtraction. So at FF03, I'm going to hit the step button, and that's supposed to store the accumulator in C. So I'm going to go to function BC, and you can see in the C register it has stored the 0, 1 from the accumulator. So I'm going to do my next step at FF04, and it should load the high order byte from the B register into the accumulator. So if I go to function AF, you can see the accumulator has been loaded with 2, 1. So at FF05, I'm going to do my step, and this is supposed to subtract from the accumulator the D register and the carry. So if I press function AF, you can see that the answer is indeed 1, 0. And you'll notice that some flags have been set. To find out which ones, I'm going to go to View, Register Contents. And you'll notice it's the auxiliary carry bit that got set. The carry bit is now reset. So I'm now going to press the step button, and now it's supposed to store the accumulator in the B register. So if I press function BC, you can see my answer has been stored in the BC register pair, and we were expecting 1, 0, 0, 1. So this is correct. Now I just want to check my A register. And you can see the 1, 0 is still in there, and that auxiliary carry is still set. We should investigate why that has happened. Notice at FF07, if you keep pressing the step key, the program just stops, because that's the restart 7 command, which just brings us back to the monitor operating system. So looking at the calculation, we do have to review our hexadecimal math. The first column contains the numbers 0 through F, and remember F in hexadecimal converts to 15 in the decimal numbering system. So if you add 1 to F, you end up with 16, so the next column over is the 16s column. So keeping that in mind, we want to subtract 10FF from 2100. Now to subtract F from 0, we have to borrow from the next column over. Now the next column over is also a 0, so we need to borrow from the next column over, which is a 1. So if we borrow the 1, we'll end up with 0. So this becomes 10. And remember, 10 is actually 16. So I need to borrow 1 for the next column over, so 16 minus 1 is F in hexadecimal. So now I have 10 in my 0 to F column. So if I take F away from 10, I'm taking 16 minus 15, and the result is 1. So the next column over, I'm trying to subtract F from F, so the result will be 0. The next column over, we already borrowed that 1, so we're left with 0, so 0 minus 0 ends up being 0. And then in the last column we have 2, which we're trying to subtract 1 from, so that leaves us with a result of 1. So our answer is 1001. And that's in hexadecimal, not binary. So to avoid any confusion, we normally put a small h in just below the number so that we can see this is 1001 in the hexadecimal numbering system, and that avoids all confusion. So in our program, what we're going to do is subtract two 16-bit numbers. So our accumulator only holds 8 bits at a time, so we start by subtracting the low order bits, so that's the first 2 of each number. So in order to do a subtraction, remember the ALU takes the number you're subtracting and it does the 2's complement of that number. So the low order is FF, which is 11111111. So we start by taking the 1's complement, which is 00000000. And then we add 1 to the 1's complement number to give us our 2's complement number. So the 2's complement of FF is actually 01. So now we're going to add that to the accumulator, which contains the number 00. So in this case, 0 plus 1 ends up being 1, and then 0 plus 0 is 0 all the way across. And you'll notice here that the carry bit will be 0. And when we do a subtraction, the carry bit is complemented, so the carry ends up being equal to 1. So our C register will end up being 01, and the carry bit will be set for this low order subtraction. The next step is to do the high order subtraction, and remember, this is with the carry bit because we're using the SBB instruction for the second half of our program. So what we're doing is we're subtracting 10 from 21. So in this case, the 10 needs to be a 2's complement representation. So 10 is 0001, 0000. So when we do the 1's complement of that, it ends up being 1110, 1111. So that's the 1's complement. To that we add 1. So 1 plus 1 is equal to 0, carry the 1.
1 plus 1 is equal to 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. So 1 plus 0 ends up being 1, and then 1 is 1, and 1 is 1, and 1 is 1. So our 2's complement of 1, 0 ends up being 1, 1, 1, 1, 0, 0, 0, 0. So to this, we're going to add it to the accumulator, which contains 2, 1. So 2, 1 is 0, 0, 1, 0, 0, 0, 0, 1. So doing that math, we end up with 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. And then 0 plus 1 is 1. Then 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. And this carry comes down, and because it's a subtraction, it gets complemented, so our carry equals 0. Now keep in mind, this is the SBB command. So now we need to subtract the carry bit from our answer. Okay, so we now need to subtract the carry bit. The carry bit is just 1 bit, so I've padded all the leading digits with 0. So this is 1. And the first thing we're going to do is take the 1's complement of it. So that ends up being 1, 1, 1, 1, 1, 1, 1, 0. And to that we add 1 to come up with the 2's complement. So 1 plus 0 is 1, and 1 and 1 and 1, and 1 and 1 and 1 and 1. So that's the 2's complement of our set carry bit. So to this we need to add our answer, and the answer from above was 0, 0, 0, 1, 0, 0, 0, 1. So adding these together, 1 plus 1 is 0, carry the 1. So 1 plus 1, 0, carry the 1. 1 plus 1, 0, carry the 1. 1 plus 1, 0, carry the 1, and that ends up being our auxiliary carry. So then 1 plus 1 plus 1 ends up being 1, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1, 0, carry the 1. 1 plus 1, 0, carry the 1. So that's our carry bit, and because we're doing a subtraction, we take the complement of that, so our carry bit ends up being equal to 0. Our auxiliary carry ends up being 1, and because we have an odd number of 1's in our result, the parity bit ends up being 0. So in this case, our B register ends up being equal to 1, 0. So when we look at our final result, the BC register pair ends up being equal to 1, 0, 0, 1. And our AF flag register ends up being equal to 1, 0, because that was the last bit of math we did. And we can see over here the flags end up being 1, 0, which decodes into the auxiliary carry flag being set. We can see the sign bit is 0. The 0 bit is 0 because it's not 0. The parity bit is 0. And the last carry bit ends up being 0. So that's why we end up with 1 in the auxiliary carry flag. So you can see with these lessons there's a fair bit of math that goes on behind the scenes. I encourage you to go through this yourself so that you can fully understand what you're accomplishing in each of these lessons.
So this concludes lesson number 6 on 16-bit subtraction. In our next lesson, lesson number 7, we're going to be looking at 16-bit addition. So don't forget to subscribe so that you don't miss any of our new lessons.